April 8, 1943. 27,000 feet above calm France, inside the cockpit of a Messerschmitt, a Luftwaffe pilot glances down at the Allied anti-aircraft fire and smirks. To him, those clunky American shells are nothing more than flying milk bottles, clumsy, inaccurate, and laughably ineffective. He's convinced that unless a piece of iron literally strikes his wing, he is untouchable. But his arrogance is about to meet a terrifying reality. Those bottles aren't just shells, they are instruments of terror. Before he can even bank his plane, the sky disintegrates. No direct hit, no warning, just a wall of aluminum rain. How did the Americans turn science fiction into a Nazi massacre? To understand the downfall of the Luftwaffe, you have to understand the rigid, mathematical certainty of the German High Command. By 1943, Berlin's top physicists had dismissed the idea of a proximity fuse as nothing more than an American fever dream. Their logic was anchored in the brutal reality of ballistics. At that time, anti-aircraft warfare was a game of impossible precision. It relied entirely on mechanical time fuses, intricate clockwork mechanisms nestled in the nose of a shell. A battery commander on the ground had to calculate the enemy's altitude, speed, and trajectory, then manually set a timer. If the fuse was set for 15 seconds and the plane was at 14.5 seconds of flight distance, the shell was a useless firework. In the chaotic skies of Europe, hitting a moving bomber with a timed shell was like trying to throw a grain of sand to hit a fly buzzing through a hurricane. The statistics were appalling. It took an average of 2,500 rounds of heavy flak to bring down a single aircraft. The Germans knew that for a shell to sense a plane, it would need a brain. It would need vacuum tubes, glass oscillators, and complex circuitry. But a shell being fired from a 5-inch gun experiences a physical hell, a rotational speed of 25,000 RPM and a linear acceleration of 20,000 Gs. To the German engineering mind, which prized precision and refined mechanics, the idea that fragile glass electronics could survive being blasted out of a cannon was a violation of the laws of physics. They looked at the American industrial machine and saw a giant that prioritized quantity over quality. They assumed the Americans were too blunt, too pragmatic to solve a problem that required such a delicate touch. This was the mathematics of destruction, as seen through a lens of intellectual vanity. Germany possessed the most brilliant aerodynamicists and rocket scientists on the planet, yet they remained trapped in a pre-electronic mindset. They were perfecting the clockwork of the past, while the Americans were weaponizing the electromagnetic waves of the future. The Germans believed the sky had rules that couldn't be broken. They were about to find out that the Americans hadn't just broken the rules. They had replaced the entire game with a technology the Third Reich deemed impossible: science fiction. While the Third Reich's elite scientists were busy declaring the laws of physics unbreakable, a group of industrial wizards in a nondescript building in Silver Spring, Maryland, were preparing to commit a technological miracle. This was Section T of the Office of Scientific Research and Development, led by the relentless Merle Tuvey. Their mission sounded like a suicide pact for engineers. They weren't just building a weapon. They were trying to shrink a living, breathing radio station into the size of a coffee mug and then fire it out of a cannon. In 1940, the term microelectronics didn't exist. Electronics meant vacuum tubes, fragile glass envelopes that would shatter if you dropped them on a wooden floor. Tuvey's team faced a problem that was more cinematic than scientific. They had to create a radio transmitter that could survive the G-force from hell. When a 5-inch shell ignites, the electronics inside are subjected to 20,000 times the force of gravity.
Recoil looks stable. Check the
It
barrel
is an
temperature.
environment of pure, unadulterated violence. The Section T scientists worked with a feverish desperation that defied conventional academic pace. They began by testing ruggedized vacuum tubes, dropping them from the top of buildings, then firing them from smoothbore guns into haystacks. They weren't looking for elegance, they were looking for survival. They poured hot wax and epoxy resin around delicate circuits, turning high-tech electronics into a solid, indestructible block of plastic. They were essentially creating the world's first smart projectile in an era of analog gears. By August 1941, the impossible became tangible. The American engineers had successfully miniaturized a 5-tube radio transceiver, complete with a power supply and an antenna, all rugged enough to withstand the centrifugal force of 25,000 rotations per minute. It was a feat of miniaturization that anticipated the silicon chip by decades. While German radar occupied entire buildings and required massive power grids, the American Section T had condensed that same supernatural awareness into a steel cone that could be held in one hand. This wasn't just an engineering success. It was a gamble with the highest stakes imaginable. The project cost $800 million, second only to the Manhattan Project. It involved over 80 different manufacturing companies and thousands of workers who had no idea they were building the brain of a digital assassin. The result was the Mark 32 proximity fuse. It was a tiny electronic predator that emitted its own radio waves, waiting for the moment those waves bounced back from an enemy wing. The Americans were no longer aiming at planes. They were aiming at the sky itself. They had created a weapon that didn't need to hit its target to destroy it. It only needed to be close enough. As these fuses began rolling off the assembly lines by the millions, the technical gap between the United States and the Axis didn't just widen, it became an unbridgeable chasm. The Section T wizards had successfully turned science fiction into a production line reality, and the Luftwaffe was about to fly straight into the mouth of a technological god. In the winter of 1941, the American industrial giant was staring at a mathematical nightmare. Creating a proximity fuse wasn't just about shrinking a radio. It was about building a machine that could survive a physical apocalypse. The mathematics of destruction at this level is terrifying. When a 5-inch shell is fired, the internal components are slammed with 20,000 Gs of linear acceleration. To put that into perspective, imagine a delicate glass vacuum tube being hit by a freight train traveling at 800 miles per hour, then immediately being spun like a centrifuge at 25,000 revolutions per minute. Every law of physics said these components should turn into a fine powder. In early tests, the failure rate was a staggering 100%. Every single tube shattered. Every circuit board snapped. The project was hemorrhaging money and time, but American pragmatism refused to blink. While German engineering sought the perfect, elegant solution, American engineers at Sylvania and Raytheon took a more locomotive approach. They realized that if you couldn't make the parts stronger, you had to change the environment they lived in. They began potting the electronics, embedding the entire radio assembly in a block of specialized plastic and wax. It was no longer a delicate instrument. It was a solid, vibrating brick of technology. But the numbers were still punishing. A single defective solder joint among the 2,700 individual connections meant a dud. A tiny impurity in the glass of a vacuum tube meant a premature explosion. By mid-1942, the statistics began to shift in a way that defied German understanding. The rejection rate at the factory remained high. Nearly 50% of fuses failed initial quality control, but the Americans simply increased the scale. They didn't fix the failure. They overwhelmed it with volume. By the end of the year, 5 separate plants were churning out 400,000 fuses every month. Each fuse contained 5 specialized vacuum tubes, meaning American industry was producing 2 million ruggedized tubes a month, while Germany struggled to produce enough standard radios for its tank commanders. This was the American way, solving an impossible physical problem through a combination of relentless iteration and brute force manufacturing. They weren't just building a fuse. They were building an assembly line that could defy gravity. While the German High Command remained convinced that glass and wire could never survive the throat of a cannon, American workers in Chicago and New Jersey were proving them wrong 400,000 times a month. The theory of the impossible was being crushed under the weight of 70 million individual components, all perfectly synced to do one thing: turn the sky into a graveyard. By the summer of 1944, the secret was out of the bag, and the sky over Europe became a slaughterhouse. For years, German pilots had operated under the comfort of a simple mathematical truth. If you avoided a direct hit, you survived. But the arrival of the proximity fuse on the European front shattered that reality forever. The Luftwaffe was no longer facing guns. They were facing an intelligent, invisible wall of fire. The first real shock came during the V-1 buzz bomb attacks on London. These pulse jet missiles were small, fast, and incredibly difficult to hit with traditional timed fuses. Before the proximity fuse arrived, British anti-aircraft batteries were firing thousands of shells just to bring down a single V-1. The success rate was a dismal 17%. Then, the American Mark 32 fuses were deployed. Within weeks, that number skyrocketed to 79%. On one historic day, out of 104 V-1 missiles detected, 68 were swatted out of the sky by shells that never even touched them. To the German observers across the Channel, it looked as if the British had developed supernatural aim. But the true horror was reserved for the human pilots of the Luftwaffe. Imagine flying a Focke-Wulf 190, banking hard to evade a flak burst that appears to be 50 feet away. In 1942, that was a miss. In 1944, it was a death sentence. The proximity fuse didn't care about your evasive maneuvers. As soon as the shell's internal radio sensor detected the reflection of your duralumin wing, it triggered a cone of high-velocity shrapnel. The result was a phenomenon the survivors described with haunting consistency: aluminum rain. When a proximity-fused shell detonated near a German fighter, it didn't just punch a hole in the fuselage. It shredded the aircraft into thousands of glittering metallic flakes. Pilots watching from a distance saw their wingmen's planes literally disintegrate into silver clouds in a fraction of a second. There were no smoking engines, no desperate bailouts, just a sudden, violent transition from a state-of-the-art war machine to a falling mist of debris. This was the mathematics of destruction reaching its terrifying zenith. During the Battle of the Bulge, The Americans took the technology a step further, using the fuses for airburst artillery against German ground troops. Soldiers who had spent years learning that a foxhole was a sanctuary found themselves exposed to shrapnel raining down from the treetops. The psychological impact was devastating. German prisoners of war spoke of a new secret weapon that could see through cover, a weapon that made the very air they breathed lethal. The Luftwaffe, once the pride of the Third Reich, was being systematically erased. They were still flying high-performance aircraft, but they were fighting an enemy that had automated the kill. The technical superiority of the German pilot had been rendered obsolete by a 5-cent vacuum tube and a block of resin. By the time the Allied armies crossed the Rhine, the German Air Force existed only in fragments. The sky didn't belong to the best pilot anymore. It belonged to the side that could turn the atmosphere into a proximity-triggered graveyard. The era of the ace was over, buried under a relentless, suffocating storm of aluminum rain. To understand the sheer, overwhelming impact of this technology, you have to look past the blueprints and into the cockpit of a man like Robert S. Johnson. Johnson was one of the most decorated American aces in the European theater, a man who survived 91 combat missions. But on June 26, 1943, he experienced a mathematics of destruction that defied everything he had been taught about survival. During a brutal dogfight, Johnson's P-47 Thunderbolt was shredded by a German Focke-Wulf 190. His plane was hit by 21 20mm cannon shells and over 200 machine gun bullets. His canopy was jammed, his hydraulic fluid was gone, and he was flying a 5-ton block of burning American steel. In any other era of warfare, Johnson would have been a statistical casualty. But as he limped back toward the English Channel, he witnessed something that stayed with him forever. He saw the German fighters that were hunting him suddenly vanish. They weren't shot down by other planes. They were erased by the invisible hand of the proximity fuse. This is the unbelievable truth of the Mark 32. It took the incredible life-or-death skill of an elite pilot and made it secondary to the raw, industrial logic of a radio-controlled explosion. The numbers tell a story of technological dominance that sounds like fiction. Before the proximity fuse, the U.S. Navy estimated that it took nearly 2,500 rounds of heavy 5-inch shells to down a single enemy aircraft. It was a war of attrition, where the odds were always in favor of the pilot. After the deployment of the proximity fuse, that number plummeted to just 310 rounds. That is a 7-fold increase in lethality achieved overnight. In the hands of a standard gunner, a 5-inch gun equipped with these smart shells became more deadly than an entire battery of conventional flak. Consider the Battle of the Philippine Sea. In a single day, the Japanese lost nearly 300 aircraft in what became known as the Great Marianas Turkey Shoot. While American Hellcats did much of the work, the proximity fuse created a literal no-fly zone around the U.S. fleet. Japanese pilots, trained in the traditional arts of evasion and courage, found themselves flying into a sky that was actively trying to kill them. They didn't have to be tracked perfectly. They just had to be detected. This is the profound contrast of the war. On one side, you had the Luftwaffe and the Imperial Japanese Navy, who believed in the supremacy of the warrior, the ace, and the perfect maneuver. On the other side, you had the American pragmatism that saw every problem as a manufacturing challenge. The proximity fuse proved that 1,000 mediocre gunners, backed by a revolutionary circuit board, were infinitely more dangerous than 100 elite pilots flying the best machines Germany could build. By 1945, the individual skill of the pilot had been outpaced by the speed of a radio wave. Robert Johnson survived his ordeal because American engineering built a plane that refused to die. But the Luftwaffe perished because American industry built a shell that couldn't miss. The kill ratios weren't just a result of better training. They were the inevitable outcome of a technological gap that German intelligence couldn't even quantify. While Germany was still counting its aces, America was counting its fuses, and by the end of the war, they had manufactured over 22 million of them. The age of the hero was being systematically replaced by the age of the algorithm. The legacy of the proximity fuse isn't found in the charred wreckage of the Luftwaffe, but in the fundamental shift of how modern wars are won. It was the moment the world realized that brilliance in a vacuum is useless without the power of industrial pragmatism. Germany chased the ghost of quality, seeking the perfect jet, the heaviest tank, and the most elite pilot. But America built a system. They understood that in a war of global attrition, information and reliability are the only currencies that matter. By 1945, the technical gap was so vast it bordered on the absurd. While German high command was still issuing orders based on the hope of a direct hit, American gunners were operating with a supernatural awareness granted by a tiny glass tube. The numbers tell the final, brutal truth. 22 million fuses produced, a 700% increase in lethality, and a total collapse of Axis air power. The proximity fuse didn't just win battles. It rendered an entire philosophy of warfare, the cult of the ace, obsolete. It proved that a nation that can mass-produce intelligence into its ammunition will always defeat a nation that relies solely on the bravery of its soldiers. This was the birth of the smart battlefield. Every guided missile, every proximity-triggered sensor, and every network-centric weapon system used today can trace its lineage back to those wax-filled blocks of electronics from Section T. The Germans called it science fiction because they couldn't conceive of a power that could blend high-level physics with the raw, thundering output of a Detroit assembly line. They learned, too late, that in the 20th century the greatest weapon isn't a better gun. It's a better brain inside the shell. History is a cold reminder that arrogance is the ultimate tactical failure. The Luftwaffe's pilots were among the best in the world, but they were flying against a tide of logic they couldn't even see. They laughed at flying milk bottles until those bottles began to think for themselves. The American achievement wasn't just in the invention, but in the unwavering belief that no physical limit was truly unbreakable if you had enough steel, enough vacuum tubes, and enough will. The thunder had spoken, and the sky belonged to America. The story of the proximity fuse is more than just a footnote in military history. It is a brutal testament to the cost of intellectual vanity. The German high command fell into the oldest trap in warfare, the belief that their superior skill and refined engineering could ignore the rising tide of industrial logic. They chose to laugh at the milk bottles, while the Americans were busy perfecting the mathematics of extinction. It is a haunting reminder that in the theater of war, the most dangerous weapon isn't the one you can see, but the one you've already dismissed as impossible. Arrogance has a price, and for the Luftwaffe, that price was paid in the silver clouds of aluminum rain. They entered the war as masters of the sky, confident in their machines and their legendary aces. They ended it as a collection of fragmented memories, erased by a tiny vacuum tube that didn't care about their courage or their maneuvers. The Americans didn't just outfight them, they outthought them, transforming the very air into a sentient predator. It was the ultimate game changer, a moment where the sheer brute force of American production met the surgical precision of the electronic age. Today, we take smart technology for granted. We live in a world of guided systems and instant connectivity. But it all began in those desperate labs in Maryland and on the chaotic assembly lines of Chicago. Those engineers proved that the bridge between science fiction and reality is built with pragmatism, iteration, and an uncompromising will to win. They didn't seek the perfect weapon. They sought the effective one. And in doing so, they rewrote the rules of the sky. This brings us to a question that still echoes through military history. The proximity fuse was effectively a cheat code for the Allied forces, a piece of technology so far ahead of its time that it felt like magic. But was it the ultimate hack of World War II? Or do you believe there was another hidden technology, perhaps the Bletchley Park computers or the early development of radar, that truly broke the back of the Axis powers? Let us know in the comments what you consider the most game-breaking weapon in history. Was it the weapon that hit the hardest, or the one that was simply too smart to miss? The lessons of 1945 still hold true today. Technical specifications mean nothing if you lose the battle for information. The machines change, the tactics evolve, but the outcome remains the same. The thunder had spoken, and the sky belonged to America.